How's my setup? No one's rating my setup? Do I look better over here? I'm a very vain person compared to on YouTube. Hello, YouTube. There's no one watching on YouTube. Today is Saturday. Maybe that's why. 10 out of 10? Can be 10 out of 10. Okay, that started. Oops. No. Okay. ठीक है. This here. Okay. Shall we start? It's kind of bothering me. Let's start. Okay. 2 waiting, but I think it's glitching. This is glitching. We're live. 8 people are watching. There we go. There we go. It was glitching. Let's start. We talked about what last time around, if you guys recall? It's a different camera angle. Yes, indeed. It's also a different place. We were talking about last time about our first reaction with an alkene. So we were doing alkenes and we did it in great detail because we were talking about the mechanism. And this is what an alkene looks like. Let's draw this bond in pink because that's the one that's going to break. So we'll use ethene as our choice. And we haven't really talked about too many reactions, have we? But one thing about this reaction is that it occurs at room temperature. It'll just happen as long as the ingredients are mixed. Okay, this happens at room temperature. And another thing is, bromine is aqueous. This is dissolved in water. It could also happen with gaseous, but you normally see it as aqueous. And what you do is you pass it through bromine water. Now, what's the color of ethene? What's the color of ethene? Can I write the equation? Of course I can. The chemical equation for this is going to be, let's get a nicer color, right? C2H4 reacts with Br2 equals to form, actually it's a better idea to write the equation down. C2H4Br2. Right? Yes. All alkenes, they're all colorless, right? And if it's a gas, it's harder to see. Take it. This is indeed colorless. What's the color for bromine? Hi, Mesam. Mesam, didn't you say hi? We can use the equation as reference for finding out the answer if we don't understand, right? What do you mean? Yeah, orange brownish. I'll just call it orange. He says orange, but he writes in yellow. What do you think is the color of the product? This double bromine alkane. So it's referred to as a bromoalkane, not that you need to know this. Hello, YouTube. Messim, you're also on YouTube again. Not again. It happens at room temperature and pressure, yes. Room temperature, room conditions. Hi. Nims is back. What's in A level AS, Nimit? I'm gonna turn off the AC. What's the question? Someone asked me a question. Oh, I asked you guys a question. It won't be orangish. Hey Asad, what's up? It's going to be colorless as well. It'll be colorless. So you also appreciate this as a gas. This is aqueous, and this is also a colorless gas, right? This is a gas. So can you picture me passing or bubbling ethene gas through bromine water, which is orange in color? And what's going to happen? What will happen? What do you guys think? What is the name of this reaction? You could call it bromination. What else can you call it? It's just bromination. You don't really आपने ठीक आंसर दिया आपने. That's probably a iteration. But you guys focus on what I'm saying. We could get to Urdu in a bit. Today we want to do a lot of content because we've spent a lot of time absorbing it, right? Now we're going to just write down a lot of equations. I want you guys to kind of, stick with it so we can throw out. Otherwise, it'll take too long for us to finish organic, and we might get late with the rest of the syllabus, right? So I want to do things fast. But quickly answer me, what's going to happen? What do you see? I'll just tell you guys because no one's going to answer me, I think. If I bubble this through bromine water, aqueous bromine, I could call it bromine water. Will I say the solution starts? Let's say this is a beaker. It's not a 1.5 hour class. I don't think we can. This is bromine water. It's brown and orange in color, right? And if I put a tube in there, oh no, that's not a tube. And I'm passing ethene into it. What's going to happen to this beaker? It'll obviously bubble ethene through it. And know that this reaction occurs at room temperature. Is the bromine getting used up? Is the bromine getting used up? Yes. Well, it's reacting with it. It's decreasing in concentration. And if you notice, the only thing over here that's not written in the equation is also H2O, which is not taking part in the reaction. That's where the liquid is. Otherwise, water's clear and you pass everything. What's going to happen? What is going to happen? The product is definitely a gas, colorless gas, right? What is going to happen? Can I say the bromine will decolorize? Bromine water will decolorize? Or the solution will change its color from orange to colorless? Yeah. Now bromine is easy to get, and if you note, this over here, this reaction is easily can happen at room temperature. What do you have to do? Absolutely nothing. Just pass some gas through some bromine water, right? So do you guys agree this is a very easy reaction to do? Sri Lanka. Nice. Yes? Okay. You guys understand this part? Let's come over here. Now, do you also appreciate bromine only reacts with the alkene because of the carbon-carbon double bond? Ethane, that's a good question. If you pass ethane through it, nothing's going to happen. It'll stay orange, technically, because the ethane doesn't have a double bond. So bromine does not react with that bond. Obviously, it's because of the bond, alkenes will decolorize bromine. Yes, that's exactly what I wanted to hear. So, sure. Why do I do that? Can someone, has anyone taken psychology? Can someone tell me why I do these things? Let's say I have 4 containers, poorly drawn containers. Do you guys agree there are 4 containers in front of me which are poorly drawn? Emphasis on the poorly drawn. I have A, I have B, I have C, I have D. So all of them are filled with either one of the following. It's either an alkane, it's either an alkene, it's either an alcohol, or it's a carboxylic acid. How can I find my alkene? Because my drawing is bad. Better? So Miral is saying take a sample of each of these gases, whatever they are. They might not be gases, they might be a liquid, and pass it through or mix it with bromine water. If it readily changes color, if bromine readily changes its color from orange and goes colorless, you have successfully identified an alkene. You can, with confidence, say it's an alkene. There will be no reaction if you take all of these and make them react with bromine. They will all be orange, stays orange, orange, orange. But over here, the alkene will change its color from orange to colorless. And it's important that you say from orange to colorless, not just say it's colorless now. No, you say it was orange, now it's colorless. It changed color from orange to colorless. Does that make sense? Mason doesn't get it. Why, Mason? What's wrong? Typical Mason? Don't say that. But why don't you get it? What's the confusing part? Mason, do you agree that bromine will only react with the carbon-carbon double bond and only alkenes have the carbon-carbon double bond? Nimnimo asks a good question. Propene, what about propene? Will this react as well? It could be a test for alkenes. It's only a test for alkenes. It's a test for all alkenes. How did I know which color? No, I'm telling you, that's the color. That's what we said. It's orange to colorless because the product is always colorless. This C2H4Br, when it forms a bromoalkane. This is called a bromoalkane because it looks like an alkane with bromine on it, right? But we don't get into the detail of it. They're all colorless. right? So you're forming a product and you're reducing bromine in the solution, so it becomes less orange. You guys, does it make sense? Can I give you a very difficult question? I think no one will be able to answer. And I feel bad giving it to you guys, but I'll give it because, if you're good, you could be better. That's my favorite meme now. I'll do that, like, I'll spam that today to the point where you guys will hate that meme. Okay, here's a question. A molecule, this is actually unreasonably difficult, so, you know. Nimnim says, no, I will. I will go. There's a chemical with a chemical formula C4H8, right? It does not decolorize aqueous. How do you spell aqueous? Aqueous. Is that probably wrong? Aqueous bromine. Draw its structural or just structure. Aqueous? That's what I wrote. Isn't that? Am I correct? Why is my spelling so bad? I would blame phones, but I have a feeling I'm borderline dyslexic. Oh, shh. Quiet down, Nina. Oh my god. Okay, people are getting it. Oh my god. It's a cycloalkane. Okay. I thought I was smart, but apparently not. I thought I was smart. This would be the chemical formula. Because you guys are smarter than I am. I don't know if I should be proud or I'm not proud. I'm just like, why? But I was happy with my question being hard. This is the structural formula of the compound. It's a cyclobutane. Cyclobutane. You have passed, Ninden. I taught you guys, yeah. No, I wasn't that smart when I was in O levels. Or I didn't have me teaching myself. Does that make sense to people? You all have to spam the salute emoji. We will make an empire, and on our flag, it'll be this emoji. I think it's almost guaranteed the next generation is always smarter than the previous one. But smart is they know more. I don't know how to phrase it. It doesn't mean the previous generation is dumb. That's what it's implying. It doesn't mean the previous generation is dumb. But I think you guys are way smarter than how old we were. Because generally of internet, how available it is. Just pick an easy one. No one knows the salute emoji. I'll show you how to make the salute emoji. Come on, guys. I showed you last time. Nimnim, you weren't here, Vasa, when I showed everyone how to do it. That's the salute. Yeah, Lionel got it. Oh, you're fast. Not happy about that. Frog. Frog. Bilal isn't here. Okay, you guys get this? I can't find it. You just type it. That's a bracket full stop underscore full stop, bracket close, 7, the number 7. Lol. Or are you talking about something else? Can we move on? Can we do other reactions? Do you guys understand this is a test for alkanes? Bromine is used, aqueous bromine is used as a test for alkenes. Yeah, Miral? What is that? Mason, what is that? Looks like a seed. Nim Nim, what are you doing? Does an alkane undergo displacement reaction? What do you mean by displacement reaction? Alkanes undergo substitution reaction with chlorine. We'll just stick to chlorine or olefins, but in the presence of UV light or sunlight. Nim, you're scaring people. Don't scare people. All right, the spark symbol. You guys get this? Okay. Spam salute if you guys get it, right? Or spam a peacock. Okay, let's continue. Let's do all of alkenes and possibly move on to most of alcohols. Okay, how much time do we have? It's already 30 minutes in. Okay, let's go together fast. So one reaction you've seen is bromination. Let's make a list of it. One, it's bromination. You could call it whatever you want. Alkene. Of course, it will happen with any alkene as long as it has a double bond. Are you guys okay with me not drawing hydrogens? I think it looks a lot clearer, but if you don't do that in the exam, you will have, well, they won't be generous with marking. Okay, that's reaction one. No conditions. This happens at room temperature and pressure, RTP. At RTP. You will have reduction. Is this reduction? 0, I think it is. Is this reduction? -1. Bromine will have a -1 charge. What is it? Bromine has a -1 charge, so technically this is gaining an electron. Gain is reduction. Reduction is gain. Yeah, this is reduction. Good. If you don't add the hydrogen, you lose marks. Oh, acha, okay. Is this reduction? I'm trying to wrap my. You don't call it reduction, so that's you're safe there. But is it reduction? I'm trying to. It's gaining electrons for sure. No, it's not gaining electrons, right? Yeah, it's not. It's not reduction. Definitely not reduction. Because what you'll have to. Yeah, I don't. Because it's. Oh yeah, the entire. Oh, it's obvious because the entire thing is adding into it, right? So it's not reduction. Yeah, actually, not too sure, Rasa. Could be, but don't worry about it. I'll say. Actually, it's kind of hard to figure out if it's reduction or not. Could be reduction. Technically, I guess there's actually no point to think of this as reduction or not. So, yeah, yeah. Mm. But, yeah. Mm. Oh well. Oh well. So would you alkenes only react with bromine or have no, only bromine. Like this. Right? Yes, Nimban? Okay. Number two. That was the obvious one. What's second on my list? Let's get some nicer colors out. I'm just laughing at the joke right now. If you add hydrogen, it'll be reduction. I got the joke the first time. It's just that now while I was looking at the empty hydrogens again, it just made me laugh. What am I doing? Sorry. Halogenation is, yeah. Uh, Halogenation is essentially, you can think of the substitution reaction as halogenation. What do you think is halogenation? You're just adding a halogen to an organic compound. So both can be considered as halogenation. But the mechanisms are different. But yeah, like we don't, only bromine will react in this particular way. Maybe chlorine requires UV light. I don't know. We don't. We'll stick to what's in the syllabus. Can I just say something? How come you always do O levels and not AS A2? You us A level students are struggling too. For us, A levels is charged. We do it on teaching circles. So Abdullah is taking a class right now. That's why I was late today. So it's there, but it's not free. Um, Maybe one day you can join us there if you like. Yeah, go to tribe.teachingcircle.one. You can go there. What is this reaction called? Yeah, that's a good question. This is called hydration because water is being added to it. You'll say hydration of an alkene. Yeah, I should have written the name. That's comes below. Hydration of an alkene. Okay. Now, what happens is this is what water looks like. We won't get into the detail of it. This is what water looks like, right? One of the water bonds breaks. One H goes on one side, the other OH goes on the other side, and they bond over here. Okay, does that make sense? Easy? Now, if everyone spam yes, then I'll continue to the next bit, which is important. So I want everyone to understand this once I go to the next bit. Lecture 3. This is the second lecture for alkenes. We kind of started alkenes in the previous lecture while ending alkenes. Is there something H3O? Yeah, but we don't. H3O plus, it has a charge on it. That's the same thing as H plus. When we say H plus, we mean H3O plus, but it doesn't matter. We not even in A levels do we look into that. So don't bother. But do you guys get this? If you're not like, come on, give me something so I can talk about this and probably finish alkenes. If the quicker you respond, the quicker we can go with class. And the quicker we do it, the quicker we finish organic. Come on, your advantage. Spam the salute thing or any emoticon. Got it, yes. Okay, TK. Now this is where people will have a lot of anxiety. The conditions for this are a nightmare, and this is probably why O-level organic is probably thought as the most challenging. Because once you lose confidence in something, you start messing up other things as well, and you become uncertain. And people will generally find this part difficult because it's nothing but rata. Right? Rata, for those who don't know, is memorization. Okay. So the conditions for this reaction is the temperature needs to be 300 degrees Celsius. The pressure needs to be 60 atmospheres. And it needs to be in the presence of a catalyst. The catalyst over here is phosphoric acid. Lionel is upset. Okay. Do you guys understand this part? Once you get it, I'll talk about these conditions. Okay? So there's a lot of uncertainty with these conditions, and it's going to give people confusion and anxiety. Okay. Now, in IGCSE, I've seen the same paper, same question, asking for the conditions for hydration of an alkene be a 3-mark question where each of these points is a mark. And I've seen the same question 2 years later for IGCSE saying you could just write something like heat plus catalyst. Huge difference between the two. But 1 year this was acceptable to them, the other year this was acceptable to them. If you had to memorize, what would you end up writing? If you had to memorize, what do you think is a better quality answer? And you will definitely never lose marks when you write it. The one on the detailed one, absolutely. And just in case, God forbid, if you can't remember it during the day of the exam, what will you end up writing instead? If you can't remember it for some reason at all, what would you end up writing instead? Yes, and that's the idea. What is worse is books, not past papers, but books will have different values. You open 3 different books, very likely they have the different values. Why? The answer is very straightforward. Why? Because people change the conditions. You can still have, so the idea is you get the certain temperature up for a reaction to take place and certain pressure. Like, think of it this way. I don't have a pressure cooker at home, right? So my mom cooks, anything meat related in a normal saucepan. But other people have pressure cookers at home, and people make it in pressure cookers. Why? Why does it need such conditions? Why does food need to be cooked? Why does carbon need to be ignited for it to burn? Why does Yeah, so the idea is economical rather than getting it done. So it will work eventually. It will work at a different temperature, higher temperature. Maybe it'll be faster, but what could be the issue is maybe you're burning fuel too much by heating the thing at a very high level. The rate of reaction is faster, everything is great. But you're wasting a lot more fuel when you heat it. And when you do that, whoever's producing this, these are industrial values. These are industrial values, and if they just don't like to do it at that temperature, maybe it's not feasible for them, not economical for them. Mohit is raising his hand. Welcome, Mohit, for one thing. What's so good? Ninim, you're saying, damn, that's so good. What's so good? We're doing alkenes, Mohit. We're doing alkenes. Take it. Does that make sense to everyone? So there's that issue. You will get different values. So do you guys understand my previous pressure cooker example? It's not like that my mom can't. Will she benefit from getting a pressure cooker? Yes, but she's dead scared of pressure cookers because she once heard it once one exploded. So after that, she'll never buy a pressure cooker. So it's okay. It's not like we don't eat meat. We do, right? And that's the idea. It's just about feasibility. It's not in Urdu. The topic is in strictly in English. Oh, when do you want to meet my mom? I don't know. Maybe one day. I don't know. Nice. Do you guys understand this point? Mohit, you walked in late. Spam, yes, if you do. If spam, no, if you don't. Lol. I will never not salute another person saluting. Also, it's so cute, the saluting thing. Everyone gets it. Now, what I've also sorted the issue. If you know the values, write this down. But try your best to remember them. But on the day of the exam, if you can't, womp womp, try this. Okay, but as a backup. But actually, a good indicator is the marks. If they're asking 3 marks for it, they really want you to earn those marks. Okay, but that's it. We'll move on. Okay, I think we're reaching the end of it. Here's another reaction. Now over here, I'll explain this a bit more than the other one. Let's say I have an ethene molecule. Let me draw the second bond because it's about to be broken. White. Okay. Now let's say I have in a chamber just ethene. And if I could, let's say, magic it, like get a wand out and like zap it with electricity, I could break only one bond. Only one bond without bromine or anything else present. What would happen? I would have I would have do you guys hear Saradullah talk in the background? Many carbons with this one bond broken. Right? Would it turn into an alkene? I guess you could say that. And it kind of does. You're not wrong. And this is the true power of organic. What's stopping this molecule from forming a bond over here like this? Absolutely nothing. But because this is also open from this side, what's stopping another one from showing up and bonding? But wait, what's stopping another one from coming and showing up? When will the class end? 7. Oh my god, it's 6:47. 7. Maybe 7:05. Okay, maybe we can squeeze in alcohol real quick. So Abdul, start. We get started. Does this make sense? You don't argue this is turning into an alkane. This is something else. The issue with this is, or what's different about this is a chain of carbon that's thousands of carbons long, if not hundreds. Keeps on going. And the products have these long chains in them. So you can't draw so many, so you put a bracket around it like that. Make sure the open bonds are intersecting with the bracket, and that's what the product is. Yeah, you're on the right track. This is polymerization. Now, the word mer is used to talk about molecules, refer to molecules. Isomer, you've heard it there, and I think one or two other places, right? Now, over here you have one molecule, and on the other hand, you have something that's made up of many molecules. What's the scientific or the Greek name for many and one? Do you have to draw this many? Up to 3 repeats is good, is ideal. I'm actually not following the YouTube chat because I'm trying to focus on the. Yeah, so this is called a monomer, and this is called a polymer. And this process is known as polymerization. What's interesting about this is the product on the small product over here is called ethene. And these chains of ethenes joined together are called polyethene. Do you guys know what polyethene is? Long chain of ethenes, clearly. But have you used polyethene anywhere? They do not have a double bond. It's called ethene because it's made of a polyethene, because they're made up of many ethenes. Of course, it's not ethene. Plastic bags. Yeah. Can you imagine? I took a gas, made it into polymers, and now it's plastic? Polythene bags is just polyethene. Polythene. All right, I don't like what's. What the hell are you talking about? I'm gonna put Nimnim. I'm sorry. I think this calls for you to be in a timeout. You guys should, you know, calm down. Okay. Plastic bags. Do you guys follow? Thumbs up. Salute. If you guys agree, or just empty sad faces if you don't agree. And this is a vast field. There's another chapter right after this. But right now, we'll just focus on this. The idea is bonds open up. Think of them as hands opening up, right? Okay. Everyone gets it. Why am I even trying? Why am I even teaching? You're welcome, Zen. You're welcome. Join our teaching circle. You'll have a few more notes, not a lot more notes. I should put it. By the way, I finally put the videos up also on teaching circle. I think some people were having issues. So those are done. Okay. Can I come back here? I forgot to talk about one thing. What is this molecule called? What is this molecule called? Zan, do you know what this molecule is called? Can you name it? Ethanol. Yes, good. Okay, you're right. So ethene can also turn into an alcohol, and they all can. आपस में you can change them. This is called ethanol. So if I ask you what is the alkene I need to use to form butanol, what will you guys say? Zen, you're absolutely right. What do you mean, Zen? Polymers and monomers? Was that difficult? We didn't. We barely talked about it. Butan, butene. Hey, don't put words into my mouth. Butene, 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 teen, butene. Thank you. Just correcting yourself. I forgot. All right, all right. ठीक है, not butane, butene. Butane does not react aside from the chlorine thing, right? You cannot get an alcohol out of butane. Does that make sense? You guys following? You guys got it? You guys got it? You guys get it? Yeah, yeah. I used to teach A levels, not this year. Maybe I will again. Maybe I will. But Sir Bilal spent so much on it. Okay. So Bilal's doing it right now behind me. You can't see him. He's in the other room. Okay. Are we done with all of polymerization? That bromine thing? Or reduction? Okay. One last one. Or I believe this is the last one. Okay. Here's an alkene reacting with hydrogen. I'm so thirsty. If you guys ever see me get me water. This time I'll draw a hydrogen just because I want an exception. What just happened? What's going on? Recording crash? What do you mean his recording crash? He's teaching. I don't know. He's talking to someone right now. What just happened? Inshallah. Thank you. I will. I don't know why I don't keep a water bottle with me. Okay. The condition for this is at 200 degrees Celsius. And nickel is your catalyst. And if you can't recall this, just say catalyst and heat. But nickel catalyst, 200 degrees Celsius. It's a good thing to remember it because these are the exact same things you end up doing A levels with, right? These conditions are still there. A nightmare, I know. Yeah, it turned into ethane. This is the same reaction that was highlighted to you guys in redox reactions where we named three, not redox, rate of reactions, where we highlighted three catalysts, or was it energy? We said nickel is used as a catalyst for there were three catalyst reactions we had to know. Nickel, or three catalysts they kept asking. Nickel, vanadium 5 oxide, and what was it? Iron. No ATM. They're out of money. This is called reduction of an alkene. Can someone tell me why it's called reduction? This is not hydration because there's no water, hydration, but this is hydrogenation. You could also call it good. You could also call it hydrogenation. And with this, you probably have an idea that all these reaction names are kind of freaking stupid, right? Hydrogenation. Jesus Christ. Come on. It gains hydrogens? Exactly, that's why it's reduction. Alkenes undergo reduction to form alkanes. Does that make sense? Yeah. Get it? Okay. We're done with alkenes. There's one reaction left, which is combustion of an alkene, which happens exact same way. The only difference is the ratio of the equation will be different compared to an alkane. Let's say you have butene reacting with oxygen to form 4 carbon dioxide. I feel this will be easier to balance. And that's an alkane. I said alkene, I wrote an alkane. 4 H2O. And you have, I think, 3 over here. No, 6. Is it 6? Yeah. And it's balanced. I think 5 more minutes. We can probably wrap up most of alcohol as well. Can I do that? Can I just throw alcohol at you guys? No. We'll write down some alcohol reactions. One alcohol reaction you've already done. What is it? Yes, I did not like what you were saying, and it's not classroom material. Oh, so apologies. The hydration reaction is Yes, of course. For alcohols, one reaction you've already done, I'll just copy it from there. Right? Hydration, that's just alcohol. And alcohol can also turn into, now note how I'm writing this equation down. Actually, let's just draw it to keep it consistent. What is the second reaction? Can you guys quit it? Lionel, no, it's not. Lionel, yeah. Guys, quit it. Chemistry only. You guys get it? Okay, the second one is just an alcohol turning into an acid. Now, they don't care about any details or anything. What's happening, they don't care. Literally, they'll write down like alcohol to an acid, but they'll call this reaction a particular name, and maybe you guys can guess what kind of reaction it is if I tell you the reagent. It's acidified, meaning you also add an acid to it, acidified KMNO4. Can you guess what sort of reaction this is? If you're using acidified KMNO4 or just KMNO4? What is this reaction if you're using KMNO4? Yeah, this is oxidation of an alcohol. Do we care about reduction of an acid going back to an alcohol? Not really. So we're safe from that. And that's it. We're like 96% done with our chemical reactions of all our organic reactions. For alcohols, the conditions are not written over here. I guess I forgot to copy it. Yes, I forgot to copy it. How will I write it down here? Hey, look at that. Right? Can we end it here? I think we'll do questions on Monday. You'll still have me on Monday. So Bilal really wants to take the class on Monday, but I think he might not be able to. But after that, he's saying he can take even Friday's class and the coming Saturday's class because he'll have time. Well, actually, I think yeah. Okay. Yeah. Okay. So we'll do some questions on Monday, and possibly, if we have time, wrap up carboxylic acids. But we're done. We're close to. Oh, the fermentation of an alcohol. That we also have to take, which is not too much. And just general an idea of. I'll just talk 2 cents about alcohols. Now, alkanes and alkenes are not water soluble. right? And if you have a liquid, they're very oily in nature. But an alcohol is something different, something unique, how it feels. It feels oily and not oily at the same time because it is able to dissolve oils because it has a, let's say, um, if I draw an alcohol over here, especially a larger one, this part is more like an alkane, which is, you could argue, is oily. But this is not oily at all because the OH allows it to be, well, polar and be able to be dissolved in water. So if you want to imagine what it feels like to have it in your hand, nail polish remover, if you've ever, I think it's actually bad for your skin, but if you've ever felt it, it kind of feels oily and thanda thanda, and yeah, that's what it is, right? Or some sort of chemical, those paint remover things, they should follow this as well. So it has that texture in it, right? And alcohols will generally have a higher boiling point compared to alkanes and alkenes because of this uh, OH thing. It just allows it to attracts more, it has slightly stronger van der Waals forces because of this OH. But not that you need to compare an alkane to an alcohol, you just need to say alcohols will increase. So methanol, the smallest, is actually a liquid at room temperature, and that should automatically tell you that they have stronger van der Waals forces. Methanol, ethanol is the same alcohol that goes in drinks, the alcoholic beverages. It's only one alcohol out of all alcohols. It's ethanol. Every other alcohol, and even this, is poisonous, but it's ethanol that goes into drinks. Ethanol is actually part of the syllabus. We go over its uses and its production, which is fermentation, right? But yeah, do you guys appreciate the part? Do you guys understand the part where it's oily and not oily at the same time? If you've ever, and nail polish remover is actually not an alcohol, but it's something close to an alcohol. All right, take it, and we can end it right now. It's already 7:10. Okay. All right, guys. I'll see you guys on Monday. Maybe you'll see Sir Bilal on Monday. Take it. All right, guys. Take care. YouTube, nothing on Sunday. Come on, I need a break. Right? Bye bye, guys. Take care. Bye bye, Nim Nim. Bye, Zen. Bye, Miral, Mesan, Lionel, Arisha, Rida. Take care, guys. Take care. Take care. Allah Hafiz. Allah Hafiz.